Well, good morning, good afternoon, good evening, folks, joining us from all over the world. This marks the start of Ring Zero's return to workshops for this Christmas season. We have 3 workshops lined up. The first one is going to be led by Guillaume Valadon, who is a Ring Zero instructor, a wizard with IPv6, and the maintainer of the Swiss Army knife of IPv6 tools called SCAPY. Guillaume is also a good friend. He's an amazing human being, and what he's going to discuss today is a small subset of his workshop, of his training that's going to be presented at Return to Exploit in February. If you like this workshop, do consider signing up for his training, and you may receive a little holiday present in your inboxes. Keep an eye for it tomorrow. With this, what I'd like to do is turn over the show to Guillaume in just a moment. Guillaume, it's over to you. You're on mute.
As usual, there is an issue with Zoom. So hello everyone, do I need to wait a little more? Or should I start right away?
I guess we can start.
Okay, I can start. So hello everyone. So I'm Guillaume Valadon. My handle on Twitter, maybe soon Mastodon, and GitHub is Gudu. And today I will give you a brief overview of SCAPY. So it's supposed to be a little bit less than 1 hour. So if you have, so that's the slide, and then I will do some demo. So that will take us like 30 more minutes, approximately. If you have any question, you can, and I guess that the best, ask me question on Discord or in the chat. I will try to answer. Unfortunately, I don't have Discord on my laptop, so I will have to answer your question on my phone, but then I will also keep an eye on the question that you have. So don't hesitate to ask me any question, and I will be able to answer them. So here we have the slides, and hopefully you can also see my slides. I will type some comments in this screen, and if it's too small, please tell me. You can again tell that in the chat or Zoom chat or in Discord, as you prefer. And briefly to start, I will start explaining what is SCAPY. So in the dojo that we'll give later in 2023, the goal of SCAPY is to be able to easily interact with IPv6, to understand the IPv6 protocol in details, and also to perform some attacks with SCAPY. And one part of the IP6 workshop is to actually play with SCAPY and understand the tool. So what is SCAPY? That's a useful tool developed in Python that is used to send and receive packets on the network. It's quite old. It's the development started in 2003 by another French guy, Philippe Biondi. So the tool will be 20 years old next March. That's quite a big achievement for us to be able to maintain a tool for such a long time. I'm one of the 2 IPv6 protocol developer. So we call that layer. So I'm one of the two person that developed the IPv6 layer in SCAPY. I did that back in 2004, sorry. In 2004, so it was a long time ago. SCAPY was really small and young. And Philippe asked me with another French guy, Pierre, to maintain the tool in 2012. And I've been working on the project since then. As of today, there is 3 official maintainers, only French, Gabriel, Pierre, and me. And we are trying to improve the project step by step, trying to keep the project alive. We are also at work to make it work on a various number of operating systems. So as of today, it works on Linux, macOS, FreeBSD, NetBSD, OpenBSD, and Windows. On Windows, Gabriel made a lot of changes to the project that make it really easy to use. As of today, you only need to install a specific DLL, which is npcap, that comes, for example, with Nmap or Wireshark. And once you have this DLL, there is nothing else to do. You can just play and experiment with SCAPY. On the other operating system, you don't need to do anything but to install SCAPY. So basically, you can just clone it from GitHub. The project is available on GitHub. We maintain it, so you can, if you have any issues with the project, issues being things that do not work, you can open an issue. If you have questions about the project, you can use Gitter. So I can show you here. What is Gitter? So that's the project page, and here you have a link, chat on Gitter. That's a specific chat system based on XMPP, where you can ask us questions. So we split the issues part, and with sorry, I lost my window. We split the issues and the questions. Okay. Definitely lost my slides. Let's go back. Okay. Yes, here. Okay, there's also documentation at scapy.readthedocs.io, that again, a link that you can find on the project page. One big point that we moved to Git and GitHub 6 years ago, almost 7 years ago. At first, SCAPY was developed in Subversion, SVN. Then it moved to Mercurial, AG, and we moved from a time where SCAPY was hosted by Philippe on his own servers. We moved to Bitbucket, still using Mercurial. And when we moved to Bitbucket, we didn't find any, let's say, new people contributing to the project, so it was kind of difficult to get attention. And when we decided to move to GitHub, it was really important for the project. We got more and more contributors, people sending issues, fixes, testing the projects. We also benefit from moving to GitHub and the GitHub ecosystem. So we benefit from CI and CD. We have automated tests on Linux, macOS, and Windows, which means that when we release SCAPY, we're pretty confident that it will work on most of the operating system we want to support. That's really important for us. It also means that when we do a change to code, we don't break things that already work. So it's really, really nice. And when we moved also the project to GitHub, it was the opportunity to measure the code coverage. As of today, 85% of the code is actually being tested. Every time we submit a new change, the tests are run on Linux, macOS, and Windows. Again, it's a big step to make sure that the project is not broken and works fine. And to install SCAPY, there is nothing really difficult you need to do. You just go to like this terminal. So if you want to play with SCAPY today, I will recommend that you use Linux, because again, there is no dependencies to install. github.com secdev SCAPY. And by using this command, git clone dev1, you just copy the SCAPY code into your laptop. And then finally, you have a directory, SCAPY, where you can just enter and run this shell script, run SCAPY, that will take care of everything, launch Python and SCAPY for you. Let me just go back to the project current status. As of today, we still maintain Python 2, which is end of life since a few years. So we decided to maintain both Python 2 and Python 3 in the project, just to help our users to move from Python 2 and Python 3. And also because from time to time, when we do testing, pen testing, and when we need to use SCAPY features on some weird and old network equipment, it's always better to have native Python 2 support. in the next few weeks or months, if we are not lucky, we'll release a new version of SCAPY that we'll call SCAPY version 2.5.0. And this one will be the last one to support Python 2. And why that? We decided when we did this dual support of Python 2 and Python 3 to end the Python 2 support when it will be too difficult for us to maintain it. And indeed, the time has come because some distribution like Ubuntu are dropping Python 2 support. Also on OpenBSD, it's quite difficult to have Python 2. It was kind of removed from the packages, main packages. So starting next year, 2023, we'll drop Python 2 support and have SCAPY only work on Python 3 because it's way too difficult for us to maintain both systems. Okay, so to install and launch SCAPY, the best way is, as I just did, is to clone it from the Git repository, and then we can experiment with the tool. So today I will describe many different SCAPY features, ranging from regular packet manipulation to more advanced tricks these TLS ones. The slide, you can get them here on this website that I can also, let me check I can also put in the Discord channel. Let me write it down. And then that's the first link on top that you can click and use. Okay, so let's start with the first things related to SCAPY, which I call packet manipulations. So in SCAPY, what you need to know is that everything is a Python object. Every packet is a Python object, like here IP and TCP. Let me check if I can annotate. So here, this is an object, and this is an object too. And this operator / is used to stack packets. So here we put TCP on top of IP, and we assign that to the packet variable. And because packet is an object, we can stack packet with this / operator on top of Ethernet. And that is a display that SCAPY will show if you type that in the shell, which is the internal representation of the packet. So, sorry, next. If you want to play with a packet and if you don't know what to do with it, for example, you want to change the IP destination address, and if you don't know which field you need to change, you can use ls on IP. For example, here you can do, let me change the tool, you can do ls IP verbose true, and SCAPY will display this. That is a list of fields that you can modify in the IP header. That is the internal type used by SCAPY to actually encode this value. So here we can see that checksum is a short field. The X means that it will be displayed as hexadecimal. And here we have the default values. 4 for version that's expected because we are actually dealing with IPv4 packets. Okay. So here, what we can do, we can actually build a SCAPY packet. What we'll do first, we'll create a TCP segment. The flag will be fin. So we'll just write flags equal fin. We stack this over an IP packet. The destination will be www.secdev.org, which is the first website that hosted the SCAPY source code. And then we stack that on top of Ethernet. And we assign it to P, which is a Python variable, and also a fully and complete SCAPY layer, SCAPY packet. Then if you do p.summary, SCAPY will give you return a string that is the string representation of your packet. Going to the shell, that's also something that we can do. You can type IP, DST, www.google.com, and we can put TCP on top. And that is, again, a Python object that we can manipulate. We can assign this packet to P, type p.summary, and that's it. We can do also many things. I will show that later with this P packet. We can access the fields. So here I'm accessing the destination field. In that case, that would be the Ethernet destination. We can also ask SCAPY to access specific fields by their name. So in that case, I will access the source address of the IP layer by using the square brackets notation. And we are also this internal, not internal, but SCAPY format strings like %, Ethernet dot src %. And that helps you to make your own Python script. So I'm just checking the Discord to see. There is no question so far. Okay. So if we go to the terminal, we can build another packet. Well, we'll call it P. Ethernet, we'll put IP. DST will be quarkslab.com. That's a company I work for, a French company doing pen test and offensive security assessment, and also vulnerability research. And we use SCAPY from time to time to look for vulnerabilities, for example, in IPv6 stacks, or actually to trigger exploits. So p.src will be a MAC address. But what if we want to access the source address of IP? In that case, I need to explicitly ask for the IP layer. So square brackets, IP, the closing square brackets, .src. Okay, that's it. And then we add the sprintf function. Let's try that. The IPv4 destination address is %IP DST %. And goodbye to a colleague. So here's not that nice because the internal representation is this net object in SCAPY, but just an example to show you how you can use this format string. So far we only built a packet, but we actually did not send it to the network. So what we can do, we can use the SR1 function. SR means send and receive at layer 3. So here we'll send a DNS query to 8.8.8.8, which is the Google public DNS server. So let's try that. So the receive packet are SR1, IP, destination, UDP, made a mistake, here, UDP, and then I will put DNS on top and close the parentheses. If I press enter, something will happen and it will be an error. So here you have an error saying permission error, operation not permitted. If you recall the line like that, it was run SCAPY. And because here we are dealing with sending and receiving packets, raw packets, we need to have privileged access to the system. So in that case, we need to, in Linux, we need to have some specific capabilities. In that case, that will be a capnet row. And another way to have these capabilities is just to log in as a root user. So let me do that. So instead of doing run SCAPY, I will do sudo run SCAPY. I will type my password, and then I will type again R, SR1, IP, DST, 888, UDP. Then I will put DNS on top, and I will send it. So here, different thing. I don't get this permission error message. SCAPY is working as expected. We have the beginning emission. We have a bunch of dots. Dots are just packets that SCAPY sniffed on the network, and the star means SCAPY was able to identify an answer to the packet it sent. And R will be the answer. And R indeed contains DNS answer. And this DNS answer is giving us the name of the query. And the query was, what is the IPv4 address of www.example.com? And we have also the answer. So to make it more easily readable, we can do R, and with this square brackets notation, RDNS. So we can see that we have the answer with the example.com question and also its address. So why example.com? By default, SCAPY is trying to use default values that works all the time. So here in UDP, we didn't specify the UDP source port and destination port. SCAPY takes care of everything, same for DNS. Most of the time, what you want to do is to actually build a query. So we decided to do that for you and ask the IPv4 address of example.com. Of course, you can change any values, but by default, this packet will go out of the network and work as expected. So going back to the slides, here's another way of manipulating the DNS answers, as we did on the terminal. SRP is a bit different. The SRP function or SRP1 function, they deal with frames, so layer 2. SRP will send a list of frames and then will return two variables. The first one in this example is called, let me try to annotate. The first one, R, is a list of queries and match answers that we can see here. The type is results. And U is a list of unanswered packets, and the type is unanswered. Okay. Oops, let me clear that. Clear the screen. Then when you have a list of packets, you can access their internal value. So R0 here will be the first packet you sent and answer you receive. R00 will be the first query, and R01 will be the first answer. So what we could do, we can access some values here. So R01 ICMP could be a way to check that SCAPY receive an ICMP time exceeded message. So let's try to guess why. Because, oops. If we go back here, the message that was sent by SCAPY is an Ethernet frame with IP on top. Destination will be 8.8.8, the Google public DNS server. And here we make the TTL change from 5 to 10. So it's a trace route. So let's try to do that from the terminal. So, sorry, trying to grab my screen. Receive an answer, SRP, I want Ethernet, IP on top. So we can also do the Cloudflare one, 1.1.1. We made the TTL change from 5 to 10. We put UDP on top, DNS, and we press enter. SCAPY say, okay, we got 6 answers. One function that I really like is end summary. End summary will print the list of queries and answers with a number. So here we can see that we got an answer directly from the fifth. Sorry, for the first hop. Okay. As you have seen in the slide, R00 will be the first query we sent, and R01 will be the first answered answer that we received. This is not really easy to use, so we decided to slightly change the way you can ask these messages to SCAPY. You can do R0 query in R0 answer. So instead of using 0 and 1, you can just name what you want and what you need. If we go back to R0 answer here, we can see that we got an answer from the server 1.1.1.1 with the actual address of example.com, which means that when we selected the TTL from 5 to 10, it's likely that we reach the DNS server below 5. So let's try to change the TTL between 3 and 5. We got 3 answers. We'll go up and display end summary. So still, this server is really close to us. If we check the R0 answer, we got an answer. Let's move to the TTL to 1. Okay. 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 Seems there is something really weird on my network. So here we'll expect the TTL to expire, but still I got an answer. So there's something on the way between my likely between my laptop and the Cloudflare server that is actually rewriting my time to leave value, because I will expect the server to be a little bit further than 1 hop away, or maybe my admins are messing with me. Likely someone is actually playing with the network. Anyway, let's go back to the slides. What we can do next with this variable R is to write them to a pcap. So pcap, if you don't know, that's the file format that is used to actually store packets into. It's used by TCP-dump, Wireshark, and a bunch of other network tools in order to store and read network packets. So what we could do, we can write a list of packets into any file we want. So ring0.pcap, and we just write R inside. You can read this packet with rdpcap. L will be a list of packets, and the beauty of list is that you can actually add them in Python using the plus operator. So L plus L will be instead of 2 UDP a packet will be 4 UDP packets. So it's kind of cool if you want to merge 2 pcap file and write it to another file again. This is pcap. It's I say the format that is supported by a Wireshark or TCP-dump. Let me show you. So I can do TCP-dump -r ring0.pcap, and then I can read these 2 packets from another tool. Likewise, you can actually sniff these 2 packets from TCP-dump and load them in SCAPY later on. Since a few months, SCAPY also supports another format, which is pcap-ng, like for next generation. This format is also supported by TCP-dump and Wireshark. It's pretty much the same as pcap with the old format, but with more features. For example, we have something in SCAPY where we can actually annotate file, annotate packets. For example, I could can do that. Ring0 R0 answer comment. I can do hello ring0. Okay. Can write that to ring0.pcap. PCAP-ng. Enable to permission denied. Why that? I don't know. Okay. That is fun. T-Shark. Okay. Okay. So here are the PCAP-ng. Can I get verbose output? Yes. And then I will need to install T-Shark to read my comments. Yes. Cool. Should do T-Shark. Yes. And somewhere I will be able to read the comments. Maybe I need to go up a little bit. Up. Let me check. Yeah. Hello, green 0. So it's a nice feature of SCAPY. You can actually write comments in your packets, save it to PCAP-ng, and open it to Wireshark TCP dump and have your comment displayed. That could be really useful when you are exploring packets, exploring new devices on the network. You can put these comments and later on check them using Wireshark or the other way around. So comment, another useful function to know about in SCAPY. Comment is used to build the real same object that is content in that case PCAP-P. So for this example of R0 answer, I can do comment like that. I will get a string, and if I copy the string to a SCAPY shell, that will be a complete Python object that I can then later on use and manipulate, and for example, send again into the network. That's really convenient. You can just sniff a packet, use command, and send it again. Eventually modify some values like the checksums, the destination. So kind of useful if you are dealing with a really unknown protocol. You want to replay messages and you don't want to actually implement the protocol by yourself. Now I'll have a look at the chat. Still no questions. Nope. Okay, so sniff, another way to interact with the network. Sniff is like TCP dump. Sniff count 2 will sniff 2 packets. We can do a little bit better. We can use sniff count 2, then use this PRN, which is just a way to provide a function to the sniff SCAPY function. And this lambda thing will, for every packet, so 2 packets that we receive, will display the summary of the packet. So here the network was actually playing with IPv6, and that is what sniff is actually displaying. Sniff, SCAPY has a lot of internal commands. A good way to learn about them is to use LSC for list commands. And you can see some of them, like the third one, ARP-ping. The ARP-ping is a convenient way to probe for hosts on the network using the ARP protocol. So obviously you can do the same on the command line with SCAPY, but ARP-ping is just a convenient way for you to scan the network without having to deal with any of the ARP, Ethernet, or another kind of layer. So ARP-ping work this way. I will just check my network range. So it should be 10.211.55.0/24. Sorry, I will do ARP ping, press enter, wait, and I have 2 answers. So I can do that. Oops. So ARP ping. I have the packet I can manipulate. Thing I wanted to show is the following here. Here, SCAPY is displaying the result of ARP ping, saying that I detected two hosts. One is .1 and the other one is .2. .1 is my gateway. That's its MAC address. And also SCAPY is able to extract the first 3 bytes of the MAC address called the OUI and display the name of the vendor of the MAC address. So here parallel means that I'm running Parallels, which is like VirtualBox or VMware on my Mac, and that this hypervisor is providing me the internet connectivity. So it's also a good way to do some cheap and simple network discovery. So LSC, so that was a ARP ping demo. Help, it's also another good way of discovering functions. So here we are using help on trace routes, and the goal is just to have the usage, how to use a trace routes. And then I will just stop a few seconds and move to another room because my colleague needs this one, and we'll be back in less than, let's say, 10 seconds. Sorry for that. And I'm back. Okay, sorry for that. Visualization. So SCAPY, you can manipulate packets, send, receive, sniff, write to a pickup, read a pickup. You can also visualize data. So this example is a bit, I guess, difficult to get and weird. So I won't describe it in detail. So the goal here is to send a bunch of packets with a function called SR loop. So that's line 15 on my slide. Then to use a Python library called matplotlib in order to plot one specific thing, which is the IP identifier, specific value in the IP header. So what we'll do here, on the x-axis, we'll plot the time. On the y-axis, we'll plot the value of the IP ID. And here we'll do a line per host that we are trying to probe. This example, we are probing 8.8.8.8, 8.8.4.4. So by doing that, we can actually, we have two lines, which means that it's likely that these are two different hosts, two different network stacks. And this kind of probing is really interesting in the case that you are probing one single IP address. And if you are probing one single IP address and you have several or two lines, like in this example, it means that it's likely that the IP address is actually being load balancing the network traffic to two different real hosts, real servers. And that's a trick that you could use to actually detect IP addresses or servers behind a single IP address. So a good way to do so is actually to visualize data. Okay, next. STR, indeed, this is a mistake. So let me use the red color. This is not correct anymore. So you need to use something else with Python 3. So STR was the old way of taking a packet like this one, PIP with TCP T on top. We used to have STR to convert these P packets into binary. But when we moved to Python 3, we decided to have a better way of doing so. It's called raw. And raw will take your packet, here P, and convert it to binary. So raw P will give you the binary representation of your packet. It's actually what is sent on the network on Ethernet, on Wi-Fi, and so on. And internally, SCAPY will read that from the network. And in that example, we'll take this value and feed it to a layer like IP. And the IP layer will actually check all of the fields. And when the IP layer will finish its job, it will call the TCP layer. TCP layer will actually check all of the fields and so on. So here we convert the IP packet to binary. And here I just copy and paste this value into the IP object. And the IP object is able to actually decode the binary content of this frame. XDump, really fun. Will just give you the same representation as TCP dump. So XDump PKT will display the hexadecimal values as well as the characters that can be displayed. Packet show will give you this representation. That's a long representation of all of the internal values displayed on a big list. We have here the IP layer, UDP, and DNS. So PKT is the previous DNS packet that I built previously. This one is used to display a PDF representation. This is really cool, for example, in slides or in reports. So here you have I will switch to blue. You have the binary representation of the packets. And here SCAPY is telling you that the IP TLL value is indeed stored. Let me follow the arrow here, 40. So it could be also nice when you have a protocol that you don't know about, you want to represent in a report or in a class, you want to teach some tricks to students to show them the link between the binary representation and the let's say the representation of the values that are displayed to the end users. Okay. One function that I really like is xdiff. So let me write two different packets. IP destination 8.8. I will put UDP. Destination port will be 41. And P2 will be almost the same, except that it will be sent to 1111. And the destination will be 42. And I can do xdiff P1, P2. And SCAPY will diff the two packets. That's again really useful when you are debugging network, trying to understand what is going on, for example, in a pickup file. So what we can see here, we can see that is likely not likely, that is the location of the destination address, 8888. The destination address on the other packet is 1111. This is 29. I should have written 41 in X. So this is 41. This is 42. And why do we have two other changes? That is the IP checksums that are different. And this is the UDP checksum of P1 and the UDP checksum of P2. Okay, next, traceroute, another function. It's like RPing. SCAPY will just ease your life and make a traceroute for you. So here we are just typing traceroute. Destination will be secdev.org, and we ask SCAPY to probe with a TTL of 15 maximum. Next. Another cool trick when you have a traceroute packet, call it traceroute, not packet, sorry, a list. We call it traceroute results. You can call a specific function called world trace, and this world trace will display the IP address on a world map, and will do lines in between these IP addresses, and that way you can see where your traceroute is actually going from your location to the final destination. So again, could be kind of interesting to display in a classroom or in a report if you want to actually show where packets are going. Make table, another more advanced usage of SCAPY. I don't want to give you too much information, but the goal of make table is to display this. Sorry, we'll select a better tool, is to display this table, and we'll ask the make table function to do several things. So we want the column names to be the IP destination addresses. We want the x-axis here to be this, the name of the port, TCP port, UDP port, and so on. And we want these values here to be the flags, TCP flags, or the ICMP error messages. And it looks a bit complicated at first, but it is super useful. In that case, we know that for the two targets, they likely have the SSH server running on port 22. This port, the lead port, is closed on the second target, open on the first one. This destination does not have HTTPS server. This one has, and so on. So it could be a really compact way of actually running a port scanner with SCAPY and comparing the behavior of the result on two different hosts. Okay, so next I will discuss the use of, okay, let me check. We have time to mention, I have a question, which is, will you have time to mention post-build dissect when layers are prepared for sending and displaying? Let me describe that a little bit later, and I will show you SCAPY source code. So the question Discord, I think, is related to the way you can actually build your own SCAPY layer. So I will discuss that a little bit later. So SCAPY has a Python module that's super simple. So here, if we want to build a ping6 .py commands, first we'll import SCAPY, and then we'll do interesting things with SCAPY. So that's only 2 lines, useful lines. Here, argparse will import a Python module that you're actually dealing with parsing the command line arguments that we are doing here. So we just say we are just parsing the arguments easily. And here we have the SR1 function, and we pass it the IPv6 layer. Destination address will be retrieved from the command line, and then we'll do ICMPv6 echo request. That's a ping. And then if you type the following, sudo python ping6.py www.kame.net, then SCAPY will send the echo request, and you'll get a reply. And because we don't see that here, but here in the end, we are calling, let me check if I can display it. Oops. No. I'm actually calling summary on SR1 that will display the SCAPY answers. Okay, so implementing a new protocol. So I will try to discuss post-build and dissect. So dissect is not really interesting because that's SCAPY internal. That's usually you don't need to manipulate. So if you want to add a new protocol to SCAPY, what you need to do, you need to create an object. So in Python, an object starts with class. You need to inherit from the packet object, that's an internal SCAPY object, and you need to give it a name. In that example, it is DNS TCP. SCAPY, if you want SCAPY to display names, when you use show, for example, you need to give a name to your packet. In that case, that's DNS over TCP. And then you need to actually tell SCAPY what to do, and you need to specify the fields description, which is a list starting with a square bracket and ending with a square bracket. We're trying to zoom out. So it's not working as expected. No, sorry. So you should check the slide online and you will get a better display. Anyway, here we'll specify 2 fields. The first one is len. I will call it len. The other one DNS. these two fields are a bit specific. Packet length field, just tell SCAPY that I want SCAPY to decode data as a DNS layer. And the field length field, I will ask SCAPY to decode first 2 bytes. And these 2 bytes will be actually the length of the packet length field. So these two fields are linked together. Field length field is actually the length of the packet length field data. So I had a question related to post build. We'll show you the source code, that will be better. Def post build. Okay, boom. Okay, post build. And post build is really interesting because if we have a look at, so dissect, let's go to dissect. So the question dissect. In dissect, you can see how SCAPY is working internally. So S is actually the data that is accessed from the network. That's a binary information. And then we'll call 3 different functions. The goal of predissect that usually we never modify is to do something before doing the decoding, like for example, changing some bytes or doing decryption if needed. Do dissect will actually read the information, for example, in the IP layer and building the binary. And post dissect is doing some modification of the message after the message has been built. And post dissect is especially important in the case of layers like IPv6 or let's call IP. So I will access the IP packet. So this is the internal definition of IPv4 in SCAPY. So that the field desk, version, internet header length, destination, and so on. And as I will explain, post build is indeed used to compute the checksum and other values. So how does that work? So post build. So P is the binary representation of my IP layer. So how does that read? If the checksum of my IP object is none, then I want to compute it. So I will actually compute the checksum with the checksum function. So I will pass P to checksum. I will receive CK, which is a binary representation of the checksum. And then I will actually modify the content of the payload by doing this weird Python trick. So basically, I'm just splitting the first part of the packet. Then I will put the checksum in the middle, and then I will take the last part of the packet. So post build is just a way to mess with the content of a message of the packet after SCAPY built it. So here for IP, IP4 or IPv6, TCP or UDP, that's how we actually change the checksum value. Post build dissect. So I think that's an answer to the question asked on Discord. So going back to the slides, DNS TCP is just a convenient way to tell SCAPY how we encode the DNS protocol over TCP. And again, that's really simple, just a value giving the size 12 and then a DNS header. From time to time with SCAPY, you don't actually want to send raw packets. You want the system to take care of most of the thing for you. So you don't want to send a SYN hack and do the full CCP handshake. So in that example, what I will do, I will use a socket. Then with the regular socket module with the SCAPY, I will connect to the Google public DNS server on port 43. And then, the cool trick, I will use SCAPY stream socket. That's a SCAPY internal object. And stream socket is used to actually manipulate a regular TCP socket, like like what we do with SR or SRP, SR1, and so on. So here we'll say, I want to use SCAPY to create a stream socket, SSCK, from the socket that we built here. And I want the base class to be DNS TCP, which means that every time I will receive data from this stream socket, SCAPY will decode it at DNS TCP. So what we can do next, we can send a DNS query. So I will build this. So it's a bit complicated. So I'm building a DNS TCP layer with DNS on top, and inside DNS, I have the DNS query to www.example.com. And then I will use the SR1 function to send it to the network. Finally, what we have, that's an answer with the IPv4 address of example.com. Okay, next. Oh, that's too quick. So something cool you can do with SCAPY is making answering machines. So with SCAPY answering machines, that's a way to make SCAPY work the other way around. So far, we've seen that SCAPY is able to send a packet and wait and match for the answer. So here we want to just follow the opposite. We want to receive something and then answer, like an answering machine. So if you want to build your own answering machine, first you need to inherit from the answering machine objects. And then you need to implement two functions. First one is named isRequest. The goal is to check that the request that you receive is interesting for you, is the query that you are expected. And if so, you need to implement the function makeReply that will send a reply to your destination. The following example is a bit specific. You will need to test it. You will need to put your Wi-Fi interface in monitor mode. So you need a dedicated Wi-Fi network card that supports monitor modes. And the goal for me is to show the SCAPY capability. And SCAPY is also able to send 802.11 frames. And that's, I think, pretty cool. So how does that work? So we have this new class. Again, we inherit from answering machine. And we define the first method, which is called isRequest. And the code here is super small. What do? We want to return true or false. So basically we say yes if the packet contains .11 probe requests, and we return false if not. .11 probe requests, that's a way that devices like here my phone are probing for access points around their locations. So they send this probe request message on all of the channels, 802.11 channels. And when they get an answer called probe response, they will be able to get the name of this access point. So next, we'll implement a makeReply. And the goal of makeReply is to pretend that we have SCAPY access points on the network. So it's a bit weird. That's a lot of information. So ultimately, that's what we want. We want to display the SSID, which is the name of the access point. We want to display SCAPY. We want to build a .11 frame, which is a lower layer in the 802.11 specification. On top of that, because we want to answer to the probe response, we'll build a probe. We want to answer to a probe request. We'll build a probe response. And then the other part, the .11 element, that's just a way to make this packet work. So we want to describe different stuff like the rates and also the channel that we are listening into. This radio tab is depending on your the value of this field. Indeed, depend on your network card. Okay, so if everything is working as expected, if you have the good Wi-Fi network card, you start this Python script, you start your phone, you go to settings, Wi-Fi, and it will display the following. So your phone, or in that case my phone, believes that there is a Wi-Fi access point named SCAPY. Obviously, if I click on it, nothing will happen because this script is only pretending to be an access point and it's not implementing any other kind of 802.11 frames. Next, IPv6. So part of the IPv6 workshop, I will go way deeper than that, but I just want to give you a small idea of what you could do with IPv6. This is a super simple message that showed really the power of SCAPY. In that example, we just put an ICMPv6 neighbor discovery router solicitation layer on top of IPv6, and we just send it. And SCAPY is magic because it will take care of everything. We'll set up the IPv6 source address, destination address, put all of the types, checksum everywhere, and take care of all of the IPv6 complexity for you. The goal of this router solicitation message is indeed to receive, let me annotate again, to receive a router advertisement message, which is a message that is sent by your router if you have IPv6, and to extract a bunch of interesting information, like here that the IPv6 address of the DNS server that my laptop need to use. I have also here the prefix on the IPv6 network and so on. So that's a way to discover IPv6 related network information. Here we can do another SCAPY trick to send packets in a loop. Here we'll send ICMPv6 echo request message to a specific address that we can see here, FFO2::1, which is like a broadcast address in IPv4. So if we send a packet to this address, all computers, all phones connected to IPv6 will send you an answer. So we use a multi-one parameter to send that multiple time, and we'll do that during 1 second. So we expect to, for example, to receive multiple answers. I will use make table again to have a nice display. What do I want in the display? I want here the destination address display here. Here I want the source address of the message and the MAC address. So why this display is interesting? So if you don't know anything about IPv6, some of these IPv6 addresses, they contain the MAC address that we can see here. If you want to know more, the answers are in the workshop. Okay, another cool trick. So SCAPY deals with Ethernet, IP, IPv6, and a bunch of other protocols. Long time ago, Philippe implemented something called SNMP. SNMP is a network protocol used to probe routers to retrieve some information. SNMP is based on ASN1, which is a really weird binary protocol. And ASN1 is also used in X509 certificates, the one we use with TLS. And the really cool thing that SCAPY is able to manipulate this X509 certificate. So let's see how it works. To do so, you will need to load the TLS layer because by default, it's not loaded. Then you can use a bunch of SCAPY internal function, like in that case, that's PEM to DARE cert. The goal is to load a certificate, like here, the GitHub certificate into SCAPY and get the internal representation. So cert GitHub, that's a GitHub certificate. We can check for many things. We can check that if the certificate is self-signed, in that case, it's no. We can get a subject. So the subject is the following. And we can get also, and that could be useful if you want to script, for example, things related to Let's Encrypt. You have a function which is remaining days, and it will tell you the number of days until which the certificate will expire. So again, simple way to build your own tools. So here, SCAPY is also able to play with signatures. So here I will retrieve the certificate of DigiCert, which is the certificate authority signing GitHub. So what I can do, I can type cert GitHub is issuer cert DigiCert. So here I want, of course, the answer to be true, which means that I'm able to check the signature of the GitHub certificate. Again, super convenient if you want to build your own tool to play with X509. This one I really like. So in that example, it's not super useful, but it shows you how SCAPY is able to deal with signatures. So here I will change the serial number value of GitHub certificate. Then I will use my RSA private key. And here, and the beauty of this slide, I will ask SCAPY to re-sign the certificate with my private key. Then I will check that the value of the new certificate, which is called new cert GitHub, is correct. So it's 0x42. And then finally, I will check that the private key, my private key, is actually the private key signing new cert.github true. So that could be super, again, convenient if you want to deal with certificates, you want to re-sign them, slightly alter the content. And if you are able to inject both the certification authority and the certificate, that could be a game changer. SCAPY can do a little bit more already to TLS. So what you can see in this slide, I'm sniffing some TLS packets on port 443. I'm sniffing 10 packets. Then I will use this really weird Python line. Indeed, that's just a list. And in this list, I will look for all of the packets that contain the TLS client hello. And why? Because the TLS client hello is the first packet sent by, for example, my phones when it's connected to trying to connect to GitHub. And this contains a lot of useful information. For example, here we can see that we have the ciphers that are supported by this host. So again, simple trick to dig and look for information on the network. Okay. And then the workshop is almost over. I won't go into that details. SCAPY can do many more things. We can automate things with SCAPY. For example, we can create state machine. We have a TCP client, which is implemented only in SCAPY. We have pipes. Pipes, that's a way to take content from one block, inject it to another, save the packet to a PCAP file, display it to a console. You can automate many things with pipes. NFQ also, that's a nice Python module that you can use along SCAPY to do some simple man in the middle, for example. So that again will are discussed in the workshop. So as I said, it's almost over, but what I would like to show you is this. If you want to play with SCAPY by yourself, you can go to my GitHub accounts. You can then go to repository, look for something called GREAC SCAPY hands-on. GREAC, that's a conference in Grenoble, that's a city in France, where I give a SCAPY workshop almost every year. And this hands-on is split in what I call trophies. And these trophies are a good way to experiment with SCAPY. For example, if you take number 2, in number 2, you have several tasks. For example, task 1, I want you to build a simple ICMP packet to 8888. And in the end, if you have no idea what to do with SCAPY, you have some hints. And if you are really stuck, you can go to the main page, click on branches here, click on solutions, select solution.md, and then you just can sit, relax, copy and paste information from the site. So here I can copy and paste put that in my, we'll put that in my shell. And then can send it to the network. This is not working in my virtual machine because the hypervisor is actually not handling this ICMP message well. I want to show you one cool stuff to show you that SCAPY is always evolving. Let me show you playing with TLS. So here, the task is to sniff SSL to TLS messages with TCP dump, and then decrypt everything with SCAPY. So let me be lazy, go to solutions, trophy number 7. So task number 2. I will go to a shell, start that. So what is a ring 0 website? I will do that with ring 0 training. It will be more cool. Okay, ring 0. So I will go to a shell and type this command, sudo. So we do that in tmux. Sudo tcp dump dash w ring 0 tls.pcap, then port 3 and host. Okay. Is that correct? Yes. Just maybe need to remove the HTTPS thing. Okay. Okay. Then I need to use this thing. This line is telling curl to actually try to contact the ring 0 website using the TLS 1.2 version. So why is that? Because I didn't find time to implement this logic with TLS 1.3. SCAPY support TLS 1.3 is, in theory, able to decode and decrypt TLS.1.3 traffic, but I didn't take time to implement it. So I need to use 1.2 for the demo. And this environment variable SSL keylog file will ask kindly curl to dump its TLS key in a file. So if I press enter, so that should be and Somil should recognize everything. That should be the ring 0 website, the HTML file. And here I managed to capture packets here. So next trick is to use this cool stuff, EditCap. That's a tool that comes with Wireshark. And I will use EditCap to actually merge the key file from curl and the pk file from TCP dump into a pcap ng file. And then I will ask SCAPY to decode everything. So EditCap should be inject secrets TLS, and that should be ring 0 training. Okay, and I want to merge it with ring 0 TLS, and I want to write it to ring 0 TLS pcap ng. But yeah. Wait. No, so it's no dash O. Okay. Something I can show you if you never open this kind of thing, that's the keylog. Keylog is just a format. So NSS keylog, it's named from the Wireshark or Netscape library, NSS, just a file format, client random, just a keyword that will be used for TLS 1.2 and below. This is garbage that we don't care. You can put whatever you want. This is the first, let's call that, it's not a key, that's the first cryptographic material that would be used to derive SSL keys. EditCap, as I said, will mix the pk files and log files. What you could do is use the strings command, the beloved reverse engineer commands on the pkapng file and grep for client random. Oops. That I don't like. Xdump. I did something incorrect. Wait. No. It's TLS pkapng. Okay. Sorry, it's being a long day in France. So what we want to strings on ring 0, TLS pickup ng, and grep client random. Okay, so we have the key embedded in the file. Internally in pickup ng, there's this notion of blocks, and blocks can be a packet or a secret. Next, we run SCAPY. We load the TLS layer, which is not enabled by default. And then you can just sit and relax. You can use RD pickup, should be ring 0, TLS pickup ng. And if I'm correct, let's press enter. I forgot. Oh, see, SCAPY is doing some magic, and obviously it's trying to be smart and decode things. So what we can do next, we can just close that. We can do l.end summary. Okay. So here we have a bunch of things like application data, blah, 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 blah. Let's have a look at number 15. L15. Okay, so demo effect, it's not working as expected. Not at all. Ah, Somil, you got me. I know what is going on. It's likely that's, okay, that will be my lucky guess. 11, 12, decrypted encrypted content. I think that the Ring 0 website is using compression, which means that's what we are actually looking at. Oh no, are you using HTTP2?
I don't think so.
Ah, that could be it. Let me check. With curl, verbose. So let's do that. Oh, I think you're using HTTP2. Wait. T'es nul. La 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 la. La la. Ah. Tomil. Not nice for instructor. So I need to do something else. Sorry, you guys. I need to do HTTP.
But this is the first time finding out. So
sorry?
It's the first time finding out. I guess it does support HTTP2.
Exactly. So that's my problem. So SCAPY is able to decode HTTP2, but then the result will be not nice. So let's do it again. Let me remove everything related to ring 0. Yes. Okay, let's prepare TCP dump. Oops. Okay. Log file. Wireshark. Wow, I need to type everything. So let's be lazy. It's late. So that will be ring 0 training. Ring 0 training for pickup parallels. Okay. So I have my key. I have the edit cap line. So edit cap should be ring 0 TLS, keylog. Then I will put ring 0 cap, ring 0 cap ng. Okay, let me check with strings. Grep client. Yes. Okay. Then Going back to SCAPY. Okay, load layer, RDP cap. Oh, what is, oh, sorry, training. Okay, and summary. So here I'm looking for this application data stuff. So I like it better with the client hello, SSL v2. So let's have a look at 16. Oh, much better. So here is the application data, and because it's HTTP1, we have the query made by curl. And as you can see, the user agent is curl, and this was actually decoded by SCAPY thanks to the SSL keylog file provided by curl. And then let's have a look at 18 and 18. And so many should recognize that the beginning of the ring0 index file. So that's it for the demo. That's it for the workshop. So I wanted to show this hands-on material that you have here on GitHub and the solution. And I think you should dig into that because there is a lot of super cool tricks that you can use with SCAPY. This thing with PCAP-NG, that's something that I implemented, I think, at first 1 year ago. And a year ago, you were able to provide a PCAP file and the NSS keylog file. And back in January or February, I implemented the way to have both of them mixed, and then try to explain to SCAPY how to decode everything by itself or decrypt. So I think it's really cool. So another cool usage of SCAPY, not only IPv6, but you can also do nice things with TLS. And that's it for me. So if you have any question, we still have some 5 minutes. So let me know. Otherwise, just go back home and I will enjoy dinner.
Folks, if you have any questions, you may either type them out on Discord or on the Zoom chat to everyone, and we'll relay them to Guillaume.
Yeah, so thank you, which is cool on Discord. Always thank you.
And while you're thinking of the questions, I will like to definitely thank Guillaume for sparing his time and the workshop. For the workshop, the videos for the workshops, for those of you who missed it, will be uploaded sometime around Christmas. So keep a check on our Twitter or Mastodon accounts and on our webpage for further announcements. 2 more workshops coming up. The next one happens to be on the 16th of December, and that's going to be led by me. I will present a workshop about Introduction to ARM64 Assembly and Shellcode. And the final workshop is an Introduction to Cryptography by JP Omasson on the 21st of December. So with this, I'd like to wrap up. Thanks, Guillaume. Thanks for attending. Thanks for your time and attention. And have a lovely evening, morning, or the rest of the day, wherever you be. Right.
Thank you all. Bye. Take care.
Bye-bye.